Welcome to the session about mapping HL7 version 2 to FHIR. My name is Simone Heckmann. I'm from Germany, from a company that's called FHIR. Just a quick few words about who we are. We are a very small, very newborn company. We offer FHIR training and consultancy for FHIR projects, professional tooling, and integration services, joined with HL7, which is another German company that is reselling the Cloverleaf integration engine in the German-speaking countries. So that's where I've been working for many, many years, doing version 2 interfaces in hospitals all around Germany. We have been involved in FHIR since 2014, and the first way we got involved into the community was trying out how to map version 2 interfaces with FHIR using our Cloverleaf integration engine. And we've been on many, many connectathons and incrementally improved our system and our mappings. And what I want to talk to you about today is basically the lessons that we learned along the way. So the scenario that we had in the back of our minds why we wanted to try mapping version 2 to FHIR is that, especially in Germany, we don't have any FHIR-enabled EHRs yet. We don't have a meaningful use incentive program, ergo we don't have an Argonaut project, ergo we don't have any vendors that have any FHIR capabilities whatsoever. However, we do have FHIR applications that companies and hospitals especially are going to start wanting to use. But all they have is their V2-based EHR. They have their integration engine that distributes all the messages throughout the hospital. And now here's the brand new world, the fancy FHIR apps that everybody wants to use. And maybe they already have a FHIR server that they can communicate with. Or you could choose any one of the reference implementation server, like the Happy server or maybe Monk, that you could use to connect these clients to. But you have to find some way to populate these servers with the patient demographics so that these apps can use this data. So what we've been looking to find was to find this missing link between the integration engine that receives the V2 messages and the FHIR server that can provide these information to the FHIR-based apps or devices or whatever we have over there. Another scenario that we had in mind is that if you have like a disparate system where you have all kinds of different subsystems, maybe laboratory, pathology, and whatnot, and they all have distributed information in different formats, and you want to have this one consolidated database where you have all the information collected in one place, in one common format, and that could also be one of the FHIR reference servers that you could use, and you would need your integration engine to consolidate all the disparate data from all these different sources into FHIR and to be able to store it in one central place. And then you could put apps on top of that and you have any kind of secondary use from your information. So the scenario we want to look at today is a very simple one, just one that I picked out of the many scenarios that we would find. And it's mapping an ADT A01 message to FHIR. Those of you who are familiar with V2 will recognize this as an inpatient encounter admission event. So this is what it looks like. We do have a classic ADT A01 message with a message header, information about the event, patient demographics in the PID segment, next of kin information, patient visit information, and a couple of allergies. So if we want to map that into FHIR, we can find a couple of FHIR resources hidden in this one message. First of all, we have the message header resource that has all the message metadata and even the the event metadata. We have obviously a patient resource in there that we could populate with the patient information and the next of kin that we can gather from this message. We have an encounter, which is the patient visit, and we have a couple of allergy intolerance resources in there. So what we need to be able to wrap all of these different resources up into one object that we can move around is the bundle resource. And the bundle resource is what we use whenever we want to have a single transaction that contains multiple resources and we want to move them around at once. It's just a container for moving stuff. It doesn't persist. It's just something that we can use as an envelope before we send something from one system to another. But there's a whole different kinds of bundle types that we have in the resource. So if you look at the bundle specification, you can see that there's a type element in there that's required and has a coded binding, a required binding to these codes. So you have to make up your mind what kind of bundle you want to use. And well, the obvious choice for what we want to do would be the message bundle, because what we have right here is a message. So, but the problem is, if we want to create a message type bundle, there's one requirement that goes along with that. It says the first element in your bundle, the first resource that goes in there, needs to be a message header resource, which again is good for us because we identify the message header as part of the information that we want to map. But in the message header information, you would have to say what kind of event this is. And there would also need to be like an agreement between client and server what this event means, so that the server knows what logic to employ to process this message. So first of all, we would have to have an understanding on the FHIR server side what ADT-A01 means, or whatever kind of other FHIR-based event we want to map this to. And also there needs to be some common understanding between client and server what this message is supposed to contain. Does this event always come with a patient and an encounter, or does it sometimes only have an encounter and not a patient? So we have to have like a message structure that is connected to the message event. So that's basically everything that we already have in version 2. If we wanted to reuse that in FHIR, that would mean we would have to re-implement the whole V2 specification in FHIR. We had to define all the events and all the message structures that are connected to these events in FHIR, and then you would have to implement each and every one of these events in your system so that your server knows what business logic to apply to a certain event. So the question is, do we want to do that? That's really a hell of a lot of work, and we will probably never want to map the whole version 2 specification to FHIR. So what do? We need a quick solution, and we have a reference server that has a full-blown FHIR API. It can do anything that's defined in FHIR, but it doesn't have any business logic. And we don't want to sit there and code procedures for all these different events, and it's going to be a hell of a lot of work. So we wanted a quick and easy solution. So the solution that we found was to use the integration engine as the brain in this interaction, because when we configure the integration engine to do the mapping, we know what this event means. We know that an ADT-A01 means that we need to add a new patient encounter and maybe update the patient demographics just in case something has changed, and that we want to add the new allergy intolerances that this message contains. So we can basically tell the server how to process the data that we grab from this V2 message and make this information a part of the bundle. So what we need in order to be able to do that is the transaction type bundle. Because there's one thing special about the transaction type bundle. We not only have the different resources that go into this bundle, but for each and every resource we also have this request part where we can tell the server what to do with this resource. We can tell the server whether we want to update or post or delete. We can give any kind of conditions that we need that usually would go into the header data of the transaction. We can just put it in this request part. So we can tell the server what we have in terms of information, and we can tell the server how to process it. So let's forget about all this message metadata. That's just, we don't need that. We just need the actual payload that's in there, which is a patient, the encounter, and the allergy intolerances. And we have to tell the server what to do with it. For the patient, as already said, we would probably want to create a new patient if it doesn't already exist. But it may be that this patient has been in this hospital before, so it's already there, and we just want to update it and not create a duplicate entry. So we don't know yet whether we want to do a create or update, so it depends on whether it's already there or not. For the encounter, it's most likely going to be a create, because that's what this event means. But we also have to consider that upon resending the message, we don't want to have a duplicate encounter. For allergy intolerances, it's a little bit more complicated because the semantics of this V2 message is a bit weird, but that's the way it is, would be to tell the receiving system to forget all the allergy intolerances that have been recorded for this patient and replace them with the currently contained allergy intolerances in the system. So let's express this in a way that the REST API can understand what we want it to do. So the first question is, how do we do this update/create if we don't really know what we want, depending on whether the patient already exists or not? So what we'd usually do is we'd have to perform a query on the server asking for this particular patient, probably by identifier or something, and then decide, depending on the number of results that we get, whether we want to update or create. But we can do this in one interaction thanks to the conditional update. The conditional update is also a put interaction, but instead of giving an absolute URL that points to one instance that we want to update, we can just put in the search parameters that we would use to figure out whether this patient already exists or not. And if the server finds no matches, it would just create the new resource. And if it finds one match, it would update the existing resource. And if there are multiple matches, it would return an error, which is basically correct for the purpose that we want to have right here. So in our case, it would look like this. We would put to the patient question mark. Our criteria would be the identifier that we have in the version 2 message. So, but what exactly would the identifier look like? We need to have a criteria that is as unique as possible, and the only thing that we have in the V2 message is probably this kind of business identifier that's usually pushed around in the V2 message. In our current example, we actually have 2 identifiers. Apparently, our patient is from England because he has an NHS number, which is a national identifier that's used in England, Great Britain, only England, I don't know. And he also has a local identifier that apparently comes from a current hospital where this patient has been admitted. We can tell that from the fact that it's just a medical record number. So in FHIR, we would have to assign namespaces to these identifiers to make them unique. So for the NHS number, we would find an OID that is most commonly used to identify this namespace. And for the hospital system, we would probably have in FHIR some kind of local URL that just simply identifies the namespace of patient identifiers for this hospital. So in a FHIR query, we would have an identifier. We would be looking for an identifier from this namespace with this value. And that's what we do with the token parameter, where we just say identifier equals, and then the system URL, whatever it is, and then pipe and the code in the back, so to make sure that our identifier only matches if it comes from the same namespace. So now here's the difficult part. How do we purge and then recreate all the allergy intolerances that have previously been posted on the server? Well, first we have to delete everything that's already there and then post our new ones. But here's the issue. What if someone else has created allergy intolerances for this patient on the server? Would we want to delete them also? Like if you have a lab system that has run a test and detected a new allergy intolerance and added it for the patient? No, the semantics is that we want to delete everything that has been previously posted by the same system, by the same source of information. So we have to make sure that we only delete the allergy intolerances that have previously arrived through the same channel on the server. So we would have to use a conditional delete to make sure that we delete the proper resources, which is basically works the same way as the conditional update. But the problem is, what's the criteria? Of course, we can select the allergy intolerances for our current patient, but how do we select the allergy intolerances that we created? So there's actually 2 ways to do that. the easy way is to simply slap a tag on every resource that we create so that we can select them by just selecting the tags and find out which are our resources and which are not. The more correct way, but also a little bit more complicated way, would be to use the provenance resource for every message that we create that points to all the resources that have come from this certain message. And in the provenance resource, we would also have a link to the device that created these resources, which would be our integration engine. So here's the correct way, the simple way using tags. In a simple scenario, we would just look for all allergy intolerances where the patient identifier is our current patient identifier from our message, and the tag is whatever tag we usually use to mark our resources that we created. And this would be the complex way, the more powerful method to use a provenance resource that has a target referencing at all the resources we created from one version 2 message, and that has an agent, which is a device, which points to our integration engine or somehow identifies our integration engine. So in this case, we could use a has search parameter, which says we are looking for all allergy intolerance resources that are linked to our current patient with our identifier and have a provenance resource pointing at them that has an agent, which is a device which points at our integration engine. So that's certainly not the easy way, but that's a very powerful way because the provenance resource also gives us the opportunity to store the original version 2 message with the provenance resource so that we can do a complete backtracing to see where our data originally came from. So now we have the interactions all in place. We have the conditional update, we have the conditional delete, and what we need now is the basic field mapping, like mapping one element from the V2 message to a FHIR resource. So there's a couple of things that are going to help us doing this. The first thing is that whenever you look at the specification of a FHIR resource, at the very top you will find a tab that says mapping, where you can find mappings to other standards. And most commonly, you will find a mapping to CDA structures, to the reference information model, and to version 2 messages. However, this mapping is only informational. It's not computable. So it's just something that you can use as a guideline, but it's not something that will automatically create the mapping for you. So there's probably, from my experience working with version 2, I'm pretty sure that there's never going to be the one-size-fits-all mapping for version 2 to FHIR, because just the way version 2 is deployed is so vastly different from one system to another that I will always have to make tiny tweaks and changes depending on the V2 system that I have. And also the requirements on the FHIR server side will be vastly different depending on the use case. Some will only use a handful of elements from the V2 messages. Others will want to have the full data that's in the V2 message. So we are probably going to be a case-by-case thing. So, but what we probably will do in the near future is to use the integration engines that are already there in the hospital, whether it's a Cloverleaf or a Mirth or InterSystems or whatever you have there can do this work for you, and you will have people in these hospitals that know how to handle these integration engines. So that's probably what you are going to do in the first place. However, in the future, we may want to have mappings that are standardized and interchangeable, that we can change between systems. Like when you move from one integration engine to another, or you have another hospital that uses a different software and you want to share whatever work you did. You have a way to do that using FHIR itself. We have a structure map resource in FHIR that you can use in combination with the FHIR mapping language to define mappings from one system to another using FHIR. What's happening? Okay, now we're back. So that's something that you could use. However, right now there's only like prototype software that can actually run these, import these structure maps and run them to map from one system to another. But maybe in the future you will have the way to import these structure maps into your integration engine or export whatever you did in your integration engine to a structure map to make it shareable. So this is certainly something to keep an eye on and see where this is going. So what we also have, and which is very nice and handy, when mapping from V2 to FHIR, we will have to do a lot of mapping for the value sets that are used, because they are, in many cases, there are different value sets in FHIR than we had in V2. And if you look at the terminology API that we have in FHIR, there's a very handy thing in there, which is the concept map resource, which is basically a mapping table from one value set to another. And we can use the $translate operation that any FHIR terminology server can provide for you, that you can call in order to let this terminology server handle the complexities from mapping from one value set to another. So that's actually a nice thing. If you want to join in making doing the exercises that I prepared, in the last coffee break, I added an example on how to use this concept map and the translate operation to actually do that. It took me a little while to find a server that properly handles this operation. It's not very commonly implemented right now, but I found one, and I also added an example concept map resource that you can use to map the patient gender from version 2 value set to the FHIR value set using the $translate operation. Okay, there's the next problem that we have to solve. When you get a FHIR message, the fact that the patient visit information in that message belongs to the patient in the PID segment is kind of implicit through the fact that it's all in the same message. However, in FHIR, we have to make this relationship explicit by linking the resources with each other. The problem is, though, that we need to reference two resources that don't have an ID yet, because there's no server yet has stored these and assigned an ID. We're just a client assembling a bundle of resources. So how do we reference resources that don't have any IDs yet? And the solution is to simply create a UUID at runtime and put it into bundle entry.fullURL. And right up before we put the actual resource in there. And then we can use this URL to reference other resources to this entry in our bundle. And the server will then replace the UUIDs with the actual URLs once it's processing the transaction bundle. So this is what it looks like on our client side. We're assigning a UUID, putting it into full URL, then comes our patient resource. And then the next entry in our bundle is our, for example, an observation, could also be an encounter resource. And we want to reference this to our patient, and we do that by just referencing it by the UUID that we previously assigned. And then the patient will update, the server will update everything once it's processing the bundle. So there's one particular aspect that we had to touch in one connectathon, which is consider you're a client that wants to to use ORU message. You want to process ORU message and send the new observations, whatever it was that the FHIR device has measured on your patient. You want to update this information in your primary EHR version 2 system. So what we actually want to do is we would only want to add a new observation resource. I'm sorry, my scenario was upside down. The source is ORU coming from a lab or whatever, and your target is a FHIR server. That's the way it is. So on your target FHIR server, you only want to add a new observation from this message, but you don't want to change any patient demographics, because the system where this ORU data is coming from is not the source of truth for patient demographics. It's just the source of truth for, I don't know, lab results, whatever. So what you can do when you create this bundle from the ORU message to reference your observation with a patient is create a patient and do a conditional create instead of a conditional update. Because the conditional create will also check whether this patient already exists, and if it's already there, it won't do an update, it will just leave it as it is. And if it doesn't exist, it will create a new patient. So, which is probably good in that scenario, but you have to consider that you as a client may not have any right to touch patient information because you're not the source of truth. So whenever you try to do any interaction on the patient, your transaction would fail because the system will not allow you to do anything on a patient. Even if you have no intention to touch it, your transaction will still fail. So what we can do right there is to use a conditional reference, which has been introduced in STU3 to pretty much resolve this issue. And in this case, we would only create the observation resource and reference not the patient by its local ID on the server, but instead by a query string that should ideally uniquely identify the patient that we want to reference this to. And then, again, the server would have to resolve this. And if it finds one match, it have to add the reference. If it doesn't find any match or multiple matches, it would have to return an error code. This is not very widely implemented yet by the reference implementation servers. I think the Happy server does it. Maybe test.fhir.org does it, but I don't know about all the others out there, whether they actually support this feature. So there's a couple of limitations when you're doing this kind of stuff. First of all, the V2 source will always override whatever changes and additions have been made on the FHIR server. So if there are other systems contributing data, maybe changing the patient, updating the patient resource, the V2 system will always override whatever has been changed there. Because we can't somehow differentiate between, I mean, of course, we could check for concurrency, but then if we find that the server has newer information than we do, then what do we do? Do we just throw away all the updates? Or, I don't know. We just have to figure out whether the V2 system really is the source of truth for the information that we have in these messages, and to make sure that, or just to understand that whatever happens on the FHIR server will be overwritten by any new information that comes from the V2 system. The other thing is that when we do this with the transaction bundle, we will process all the data that we put in there, but there's no trigger that invokes any additional actions on the server. Like if the server maybe has to open an account locally whenever a new encounter is created, which is not part of the V2 message, but is part of the server-side business logic that needs to be triggered whenever a new encounter is created. That's not something that we could cover by using a transaction. In that case, we would actually really need either a message type interaction or an operation that we could call on the system that could trigger whatever business logic the server needs to perform upon the arrival of a new encounter. The next thing is merge is tricky. Like, if you want to do a merge with just the REST interaction, that's really difficult because in a merge you would have to basically iterate through all the references to one patient and kind of change them to a reference to the other patient instead. That's probably something that we could only do through an operation that as a client we call this operation, say, hey, we need to merge these two patients, and then the server can do any kind of background search for whatever resources it needs to update. So the next problem is that this doesn't work in the absence of REST. So if you can't communicate on a REST-based API, this pretty much blows up. So that's basically where messaging comes in. If you have to route the messages or do file transfer, or I don't know, write it on a disk and carry it around, whatever you have to do to make your interaction work. You would probably be better off with a message type bundle, because this has all the metadata, like where does this message come from, when has it been created, and what's supposed to happen with it. Then the next problem is that when mapping from version 2 to FHIR, we have a kind of, it's pretty inaccurate to decide whether our PV1 information is actually an encounter or an episode of care, because these two concepts have been pretty much collapsed in FHIR. There was no differentiation between the two. So this might, in some cases, be a little bit problematic to decide what it is that you actually have in this version 2 message. So the next problem is, if you're working with a FHIR reference implementation, you're good because they implement everything, all the fancy stuff that we use, the conditional updates, the conditional reference, it's all there for you to use. But sometimes you will have to talk to FHIR servers that only support the basic REST interactions and none of the fancy parts of the API. So in this case, there's one solution that we actually implemented and tested in one connectathon, and it worked pretty well, is that it's pretty easy to write a script that kind of emulates the transaction and kind of splits it up into the individual operations that it would actually have to do. Like a conditional update is nothing else but a search, and then depending on the number of results, either an update or a create. Or the conditional delete is nothing else but searching all references that match a certain parameter, iterating through the results, delete all of them, and then post all the new ones. So whatever we have in this transaction bundle, it's pretty easy to write one fairly simple script that goes through all the conditions that are in this request part of the bundle and kind of split them up into individual interactions, and then depending on the result of this, decide what next step to take. That's just something that you have to create once, and then you can feed it all your transaction bundle, whatever happens, and it will basically split it up into simple REST interactions. So my most favorite quote from Graham is, you can move complexity around, but you can't make it go away. And this is once again very, very true for the scenario that we are talking about. Because we have different options how to handle the V2 mapping, and depending on which one we choose, the complexity moves from client to server. So if we do a plain REST interaction, we have basically no complexity on the server side at all, because the client is handling all the orchestration, like what steps does it have to take, how does it have to react depending on the number of results. It's all happening on the client side. With a transaction, we have a kind of a shared complexity, because for the client it's pretty difficult to put together all these requests information, the conditional strings and all that kind of stuff, whereas the server has to implement at least the conditional update, the conditional delete, the conditional reference, and resolve everything accordingly and update the references and all that kind of stuff. With a message type bundle, we have very little complexity on the client side, because we only have to map the actual information in the system, but we don't have to concern ourselves with any kind of business logic. We just map the information, throw the message bundle at the server, and the server has to figure out what business logic to use to make sense of the information that's a part of this message. So we talked about this one way to get patient demographics from a V2 data stream through the integration engine into the FHIR server. But we also have to think about the way back. Like if we want to, if we consider these devices to be some kind of measurement devices or home care or wearables or whatnot, they will probably add observations, like whatever they measure about the patient, to the server. And we want to have this data back in our V2 system as an ORU V2 message, because that's the only thing that this system actually understands. So what do we have to do? Somehow we have to figure out whether there's new data on this system, which we can do through the history interaction. By querying a FHIR data for its history of all observations, we will get a bundle in return that will tell us about all the observations that have been created, updated, or deleted on the FHIR server in a certain period of time. And from this bundle, the search result bundle, we would then be able to create the ORU messages, but only after running another interaction with the FHIR server, because in order to create an ORU message from just an observation resource, we will also have to have at least some basic patient demographics and at least basic information about the encounter that needs to be part of this ORU message bundle. So the history interaction has one advantage. It's pretty reliable, because if you miss polling the server because your integration engine has been down for maintenance for an hour, you can always save the timestamp of the last successful polling, and whenever you do a repoll, you will always poll for the interval since the last successful interaction. So it doesn't matter if either the system is down for a certain period of time, you will always pick up where you left off and you will never miss a message. It's pretty simple to implement. If something went wrong when processing the data, you could just repeat your query. The problem is, though, it's not selective. You can only query all of the observations, but you cannot select and say, I only want the blood pressure. Also, there's a delay, because you have to find a sensible polling interval. You can't poll every second. That will be too much traffic on too expensive on a system. But if you poll like every 5 minutes, you will have a delay of worst case 5 minutes before the data arrives in your system. Also, you need to have the second interaction to include all the other information that you need to put together your V2 message. Subscription is another way to accomplish that. By using a subscription, you will post a subscription resource on the FHIR server with a search criteria telling the server what you are interested in. And whenever anything that happens on the server matches your criteria, you will receive a ping from the server, and you know that there's new information there that you can query and retrieve, which is good because it allows some kind of real-time interaction, and it also allows you to be very selective. Like if you're only interested in a very small percentage of all the observations on this FHIR server, you can give an exact criteria, and you will never miss it whenever something matches your criteria. So it's a much lower bandwidth that we have here, because we only get the stuff that we're interested in. But on the downside, it's difficult to implement the queuing. Like at this time, there's nothing in the specification to say how to handle that. Like, what if the system sends you a ping and your server is down and doesn't receive it? Does it re-ping, or what's happening? It's not really defined in here. So the other thing is, in the subscription, we don't have a trigger that tells you if anything is no longer a part of your criteria. So if anything drops out of your selection, you will probably miss that because it doesn't trigger your subscription. So there's currently work going on in improving the subscription. So if you're interested in that, please look at it and give us feedback on how to improve this. But at this time, these are basically the two things that you can do to get information from a FHIR system back to your server. So what's happening next? First of all, if you're interested in creating mappings from V2 to FHIR, join us at the Building Bridges table. That's where we are going to have our hands-on session. I'm uploading the description of the exercises to our homepage. It's www.gefira.de, attention, de, not .com, /DevDays 2018. And that's also where I updated the exercise to include the using of the concept map to map the value sets from one by using the terminology API. So that's only in the latest version on our homepage, not in the paper that you will get around here. And also on this page, you will find the solutions to the exercises. So if you want to take a shortcut and not do all the work and just look at the results, you can also find this here. So if you have any questions, if you get stuck doing these exercises, please use the FHIR chat. We have a V2 to FHIR stream already existing in this chat. It's pretty deserted actually, but I added a new message this morning to make it go up, pop up in the stream again. So please use this stream on chat.phir.org. Like, I will be running around all over the place. I will probably not be always at the table. So if you have a question, please just use the chat. I switched the channel to be really loud and noisy and notify me with push notifications. So I will be able to get back to you quite quickly, so you don't have to run around and look for me. So whenever you have any question about the sessions, please use the chat. So speaking of translations, there's one final note. The FHIR community kind of attracts a certain kind of people that have appreciation for the nerd culture, I would like to say. So it was only a matter of time until a translation of the FHIR specification appeared into Klingon language. So if you're so inclined, we have a little shop right there where you can get any kind of stuff like hoodies or t-shirts or mugs or whatever with the original Klingon FHIR logo. And cool is actually that's actually the Klingon translation of the word fire with an H put in the middle, because that's what we do. So if you like this, if you think cool is cool, then yeah, you can go there and get fancy t-shirts and all that kind of stuff. So enjoy. And if you have any questions, please ask me. We have 5 minutes for questions. Anyone? Nope. As I said, you can find me around here or in the chat room or wherever. Any questions, just ask. Thank you.